for the opportunity to present this to you guys. I hope you're going to learn some. We will be able to work with some of you maybe in the future. But the main thing is like Stuart said, is we're going to have a little bit of a discussion regarding noise and vibration monitoring for asset management. Now, myself, I'm technical sales manager at RS Clay, as well as account manager for TFL. And I've been with RS Clay now for quite a few years, and for about 5 years now actively in rail. And this is definitely something that is very interesting for myself, and I hope you'll find the same as well. So without ado, let's look at what we're going to have a chat about today. Let me just get this. So the agenda for the day, and it should be about 45 minutes, and then there's time for some questions as well. The first is using rail for noise and vibration, in the railways. How can we use it, and what do we look for? Then there's also continuous data capture. What do we do, and how we do that? And then the next one is this infrastructure. We're looking then specifically at the infrastructure asset management, and then fleet asset management, and then the pantograph monitoring as well, and then just a summary at the end of what we discussed. So the first one is using rail and noise and vibration as a tool. Now, I think firstly we have to understand that due to friction, we have wear and damage that's taking place, and when wear and damage take place, there is also noise and vibration that go with it. So we can almost say that wear and damage is equal to the noise and vibration that we're getting when the damage is taking place. Now on this, that's one, two. Come on. So on the chart here, you can see we have different frequencies that we're looking at, and this is something that we have to understand right from the beginning. Is we're looking specifically at the wheel rail interface. What's the noise in that specific area? Because there's various noises that's on the train. Everybody that's been involved with the railways will know that there's quite a bit of noise when a train is actively working. So how do we then determine what noises we are looking for, and how can we eliminate some of the other noises to pinpoint and find a root cause, for a solution? So these are just examples of frequencies. For rolling noises, it's usually between 30 to 2,500 hertz. What you'll also see here is that many of these frequencies will be crossing each other. So you won't have just one frequency for one specific, but there is then ways that we can eliminate those and get straight to the point of what the problem is. So like rumbling noises as well, but the main ones that we're looking at is, of course, the top of rail squeal, and then the flanging noises as well. Those are two that we're specifically looking at, as well as, of course, corrugation is one of them. But these will be all speed related. So as soon as the train goes faster, your frequencies will change. But again, we have, or the system is able to distinguish between those increases and decreases in speed then. So that's how we look at it, from a basic point of view. So the next thing is then what we want to look at is continuous capturing. So this just adds on to this specific point to say, well, how can we distinguish all of those things? You can just go stand next to the rail and you can measure the vibration. As you can see across my shoulder, there's a equipment that you can just put next to the rail and you can measure it. But that's a once off or an annual measurement that you're doing, which is fine. It works fine. We have the same equipment and we use it, and it's quite successful. But if you want to do a little bit more with noise and vibration, you need to expand that to continuous data. So you continuously need to get information into a system or into a server so that you can do the analysis of it. So the main thing is, and I'm not going to go through all the points, I'll just do a brief discussion about those points. But if you, depending on where you are in the world, you can have different environmental impacts on your testing. And also, if you stand next to the line, it can be one train or two trains that's coming past, depending on the time that you can spend next to the line. Now, as engineers and managers, we don't always have the time to stand there for 5 or 8 hours or how long it's necessary to get all the trains that's coming past. So it's much better to have a continuous monitoring that you can do. And just to give you an example, just to make it also a little bit clearer, if you take in a year, there's 8,760 hours in a year. That's a normal year, leap year a little bit more. But if you have those hours, and you can do 8 hours on a monthly basis, so it's 12 times that you're going to do 8 hours. That's 96 hours of testing that you can do. That's only 1% of the time that you're going to spend to try to find a root cause of a specific issue that you have. So what we're saying is, and even if you break that down, because you won't be doing, or the train won't be running for the full 8,700 hours. So if you break it down to a quarter of that time, you will have 4% of the time that you're spending, and then try to find a root cause analysis. And what we're trying to say is, if you do continuous monitoring, you can continuously then capture data, and then of course you have to find a way to do analysis of that data, because that will be quite a bit of data that comes in. And that actually brings then to the next slide. Where you can see the amount of data that we're getting in. As if you do continuous data capturing, it's 70 to 100 parameters per second that you're gonna record. Now, if you start timing that over years, because you have the ability to do trend analysis, so if you start adding all of that up, that is quite a bit of data that you have in your service that you have to go through. And it's not possible for any of the engineers to sit down and really do that. So what we bring then is we have a system that have smart algorithms, written specifically to pick out those frequencies that we spoke about earlier. And when you have those frequencies in place, the algorithms can show you where issues are. And it will basically then create a heat map like you show at the bottom here. And that's also a point, and we'll discuss that as the presentation go on. There's various dashboards that you can pick, or to do the analysis of the data that you're getting in. And these are only two examples that you have, of what it is. So all of these algorithms is written in, and then there's AI also that's working in the background for neural networks, to basically get all this information in a manner that everybody can read it, easily, and then of course that we can keep on repeating this data that's coming in. And if there's any changes necessary, and it's not a system that we just supply to you and you go and say, well, this is how it works. You need to do a little bit of tweaks, because all the networks will be different. It will depend on the wheel sizes, on the wheel profiles, the rail profiles. All of those things will play a role in what the frequencies that will come up. And we and our partners will then work with you to get a specific point or specific readings, so you can have the right information to make a root cause analysis, or to do a root cause analysis. So big data assessment, management. So what does it brings to you? As a service, we can bring all of this information in, and like I said, is you have to find it easy to determine what the issues or the root cause is before you can put a solution down. And the system was easy clicking, one click away, and you can have information with you. And like I said, there's various dashboards that you can pick, and they're also customizable. So if you want to look at a specific type of issue and you want to see it in a specific way, whether it's with graphs or noise monitorings or whatever you want, we can work with you to give you a dashboard that works with it. And then if all of this is also real-time monitoring, because we put equipment on the trains, so it's something that we will discuss later on in the presentation. and it's real-time information that you get, but it's not just real-time. There's archive data that's also there, and that gives you then the possibility to do trend monitoring. And trend monitoring, there's a slide that I will show, which is very beneficial and also cost effective, to save money. And all of us want to save money at the end of the day. And then the big thing also is for live data. When anything happens, anything can change very quickly on the railways. So there's the possibility to have alarms set on these frequencies. When a certain noise level is reached on a frequency, it will definitely make an alarm then and notify the user that there is an issue that's coming forward or that on the line. And a good example of this is actually a few months ago. There was a neighbor or a person living next to the rail here in the UK that was listening to the line and said, "Oh, but as the trains are passing by, the sound is quite different than what he's used to." And he spoke to Network Rail about it. They did an investigation and they found that there's a broken rail that they could fix, and there was no bad accident or severe accident that took place just because of the noise, the change in the noise. Now that was a person that heard it. This system will pick up all these type of things, as the train is running up and down the network. So anything like this will be picked up, and it can be a lot. So when you have all of this then done, that will enable you to look at your the assets and do predictive maintenance. Something that currently is maybe not always done, it's not predictive. It's more reactive, and it can also eliminate then all the environmental noise and vibration that we get, and also fewer complaints, because that's the main thing is the people and all the stakeholders around the network that's complaining about the noise, and improve the passenger and the driver comfort. So that's what we get out of all the data. We collect all the data, we do the analysis of the data, and then helping you to improve your network. Not only by improving it for your customers, but also by improving it by reducing your cost that you spend via maintenance, and of course time as well, saving you with time. So the next part that we're looking then at is the infrastructure asset management. So here we're looking at specifically at the infrastructure, the rail. Like I said in the beginning, we look at the wheel rail interface. That is the part that we're concentrating on. And what we want to do is monitor what's going on the rail. And we're doing that by installing equipment on the fleet, on the rolling stock. Excuse me. And this equipment will then enable us to monitor for curves, squeals, flanging that's taking place, any corrugation that's taking place, or any other rail defects like I just mentioned. Maybe crack rail or broken rail that will cause it. Even flat spots on that specific train will be able to pick up. And then all of this information again, it's a one spot or hotspots will be indicated very quickly when there's a noise and vibration, and then that will give the engineer the chance to investigate those specific places where there's curve or corrugation issues that's going on. And this is done across the whole network. So as the train is running up and down the network, that's how this is done. And it's not necessary to install on all the trains. You only need to install on a few trains, preferably if they're different trains running on one line. You then install on each of these different train sets, you install one of these units to get the data from that specific unit as it runs across the network. But like I say, it's not necessary to do on all of the machines or all of the trains. Yeah, and all of this is then tailorable. You can tailor, however you want to do the monitoring on this. So the equipment, for the infrastructure, like I said, you put it on the install it on the trains. What we have here is the monitor, just a sensor or a mic that's fitted and protected for dust under the train, and you have vibration sensors that you put below the the suspension of the train close to the wheel journals or the wheel bearing journals, and that will then pick up any vibrations that's coming through the wheels onto the train set. You also have a GPS system, excuse me, a GPS system to determine where the train is in correlation to your network. There's also, if you have a lot of tunnels or maybe like the network of London Underground or any other underground services, there is another way to pick up the positioning, and you can't use a GPS in those cases. So we'll have to then talk to the fleet to get different information from the trains of where they are. You can also have a camera. This is optional and is usually used. The camera is usually used for the pantograph monitoring, but we will get to that a little bit later on then. And this is the example that I spoke of earlier, where train monitoring helped the customer to find a solution. First, find what's the root cause, of the noise, and then they were able to put a solution in place, and then it actually shows how the solution was running over the next few years. So the top and bottom, the top one is your L maximum readings for noise, and the bottom one is the SEL noise. So that's the SEL stands for sound exposure level, and that denotes as a LAE, which is an acoustic parameter used for the measurement of total energy of the sound event as if it happens in a second. Now that's usually used then to be able to compare noise between different sound energy levels that you get, and that gives you a good point of the comparison. The one I just want to show then is the top one. If you look at the top or the bottom one for that matter, you have a very low noise, and then there's an increase in noise, and that increase in noise was then found is as corrugation is forming on the rails. Then you have a specific point here where the grinding was done on the rails, and as soon as the grinding's been done, you then have a starting point again very low, and as the train starts moving, you then have an increase again in the vibrations, in the sound. Sorry, in the sound levels. Well, that increased then to a specific point. Again, they did the grinding. There's a reduction. And then again, you can start seeing there's an increase that's happening here. Now, what the company then did is they did the grinding work, and after the grinding work, they did top of rail conditioning by adding a top of rail control material to the rail, friction control material. Now, when they applied this top of rail friction control material, that stopped the wheels from slipping and lateral forces and help with the steering. And then, of course, that's a reduction in noise is the first one. But the big one is there's no corrugation or limited corrugation forming on the rail. And there you can see there's no increase in noise over this period of time. If you look at the graph on this side, that's about a year. They had to do grinding on a yearly basis. Once a year, they did the grinding. And this one, they ran from July to July with no corrugation or no grinding needed. And then, of course, going forward, no grinding needed, even going into the new year. And that can save you quite a bit of money and time where you need to go and work on a line or do the grinding and repair the line. It's man hours, and then, of course, capex that you're saving on that for that. And of course, at the end of the day, it's also rail replacements. The less you grind, the less replacement you need to do on these lines. The next slide is then just again as an example of what you can get when you use the dashboards. So this specific one is a one-day event, where you have a 1 day of data that's been collected and put into the system, and you can then monitor and see where's different vibrations taking place at different times. This one, I would say this is more towards the pantograph. This is a video of a pantograph. There is one that we'll show later on, and then just photos that's been taken at specific times where there's maybe an alarm setting that's on the unit. And then if the vibration or the noise levels get to a specific point, it will automatically start recording the video and also the audio as well, to give you an idea what you are listening to. So it's not a thing that maybe a car that backfire in the background and you think, well, that's a problem on the rail. You can listen to the noise itself, and you can then see, well, it's from an outside or it's an inside noise level that you're looking at, and whether it's necessary then to do the work on it. And there's different ways, like I said, there's different dashboards that's available, and you'll see a few as we go on. So this specific one here as well. So you get the heat map that you see here, and then you have at the bottom, it shows you the 1.5 million data points that's been collected. So that we spoke about it earlier, as all the data points that you have. So you distinguish the data points, what's the noise levels, and then it puts it into this graph. So you have these different ones, and you can then pick what you want to look at. If you want to look at these specific ones at the bottom where you have the very high noise levels, you can highlight it on it, and it will give you then a specific point, where you have all the noise that's taking place. That will then, as you go deeper in, you can then see what's the frequencies, and there's different graphs again that you can look at these frequencies that's happening. And that also takes in consideration the weather, so you can monitor the weather that's taking for the day. As we said in the beginning, weather have a big influence on your outcome or on the data that you're collecting. So it's all of these things you have to take in consideration when you start looking at your noise and vibration readings and the data that you're collecting. Another example of a dashboard. This one, for instance, what has happened is they switched on specifically for the squealing noise to look at the squealing on the network. So you have that specific frequency that's been looking at. It's been highlighted here at this end. The noise level's been highlighted, and that then gives that this specific curve here is where there's a squealing noise with a noise reading higher than 110 decibels. At the bottom, it just gives you again the whole network and where all the squealing noises are on the network. And that is, well, as the trains are running, it is measuring. All of this data also, just to show it at the side, is all done and based, or the measurement of it is based on the DIN and the ISO level. So it's all legit the way that it's been done. And just interesting also is that currently there's no mandatory noise limits in the EU. There's no regulation regarding that, and the same in the UK as well. It usually falls under the nuisance law in the UK. And that is for including night times. So you can think yourself, if you have freight trains that's running at night, people will most probably complain if there's a lot of squealing going on or flanging. So yes, people would want to reduce that. And then for my infrastructure dashboard again, and again, just examples. I'm not going to go too deep into this again. It's just again different examples that's of dashboards that's possible. This specific one here, you can move the red line, and that will give you then different. As you change the red line, it will change the frequency or the noise levels, and as well as the frequency. So that determines the frequency where the noise is. So this specific one where it is now the high noise at around about 88 decibels, and that is at 2100 hertz, which is usually indication of top of rail issues. So yeah, you can then start looking at that specific point. What's the issue with the top of rail there? This is a frequency spectrum again. It's against time and the frequency and various other ways that you can monitor it. But the main thing is just looking at the infrastructure. What we're trying to achieve is, now this doesn't work. Oh, gentlemen, I'm sorry, I'm not going to be able to show this then. I'm not sure why that's not working. So what happened is, or these videos, I've got 2 videos here that just show the noise of what we want to achieve is before we apply a solution. So we do the measurements, you get a noise in, and then afterwards, what the results will be as soon as the solution is in place. Unfortunately, I can't show. I don't know. I did test it beforehand, but now suddenly it doesn't want to work. So apologies for that. The next slide is what we're doing is this fleet asset management, and this is specifically looking at the trains that's passing by. These units are set next to the track, and then accelerometers for vibration monitoring is placed on the rail, one on the left rail, one on the right rail, and then you can pick up anomalies on the train wheels, maybe bearings. You can even pick up other noises from systems like failures of air conditioning systems, maybe engines that's making strange noises. As long as you have a benchmark before, and then you can test afterwards as the trains run past, if there's any anomalies on the sound as they go past. Again, there's dashboards that you can use, and you can set them up as you want. This specific one, we're looking at the left-hand rail, and then also again the right-hand rail, the different vibrations that you have, and then the overall noise, and then you have different graphs, and you can set up these graphs as you want to set them up, whatever you want to look at and how you want to do analysis of these vibrations. So these 2, just as an interest here, as you will see, there's high spots in red, so there's very high vibration levels, and these are only on the left. So that's each number that you see here is a number to a train. So it's a specific train that's going past that's been recorded, and then it picks up that on the left-hand side there's an issue with something. So you can now go deeper into that specific train and try to find out or do an analysis of what's the issue with that noise, or where the noise is coming from. The same again on the right-hand side for the same train. There's no issue there. And then this specific train here, you have a left and a right, so there's something going on both sides, and so on and so forth. The ones that's green that show that all the noise measurements is the same as what it was against the benchmark that you did previously. The bottom one is noise, and this most probably show that you have maybe 2 or 3 different train variations that's running on the same line, passing this monitoring equipment. So you have a train that have no noise, and then one that have maybe some noise, and then one with or a train set that have quite a bit of noise, or a type of train that have a lot of noise. And that can be related to the wheel profiles, anything that change on the trains. But that gives you then the idea to look at what's the differences between the trains to find out what is creating the noise. So again, just a lot of these dashboards, you can customize them as you want to use them. It will suit you. And then we have the pantograph monitoring. Again, it's a graph. This specific one, there's a vibration on it. So this graph shows that there's a activity that happened at this specific point, and it gives you actually on the map where it happens, and that gives you a spike that goes through. And then of course, it gives you the map, the live alert. There's an alarm that will come in, if it's set like that, to give you that alarm. And then of course, if you can catch that, that's a lot of cost that you can save regarding to the country, the pantograph, the replacement of buses, because if the trams are not going to run or the trains are not going to run, you have to put buses into play, the human hours for repair, and of course the reputation of the company. Now, unfortunately, the next one is again a video, and I don't think this is gonna run. No. So this is a video just to show how long a train actually run before the power is switching off, and the amount of damage that occurs on the line and with the pantograph, the train itself. So the cost with that is a huge problem then for the fleet and the company that's operating them. And that brings us to the summary. What does this mean all to you? The main thing is you're getting a system. All the data that's coming in is a system that monitors real-time infrastructure and rolling stock. There's different dashboards that will help you, do analysis of the issues that you see, and all of those things are also then managed in the background with a AI and the algorithms that's in the system. There's real-time audio overlays. Like I said, is you can have an overlay. There's a setting that you put exactly at what level the audio is being recorded, so you can then go listen specifically what is the noise that you hear or that they record in that specific point. And reduction of the noise and the vibration for the environment, because it identifies the curve squeals and the flange wall spots, and of course the emerging of corrugation and roughness. When you do a trend analysis over those periods of times, you can see when you have to do grinding, so you can plan for it, or you can find a solution to mitigate specific grinding or issues that you're having. And of course, then at the end of the day, it improves safety with less people on the track. You reduce the cost. Any issues that you find, you can have people going specifically to maintain it, so you can plan for your maintenance and not being reactive. And then, of course, most importantly, to reduce or improve the comfort for the passengers and for the drivers. And just as interest, all of this was implemented in Amsterdam, and since it's been implemented, they had about 42% reduction in noise complaints from the people in Amsterdam. So yeah, the question is, how can this technology assist you? So any questions? Thank you.
Thank you, Frans. Very interesting presentation. I guess with a lot of opportunity for maintenance-based people. Certainly the way that you've explained the sort of process of understanding the noise and how that would assist. So can I just start off with something you may have addressed at the end, actually, but a number of people have asked. It's just really, you mentioned London Underground and you mentioned Amsterdam. Where has this system been implemented and for how long?
Oh, it's been implemented in Amsterdam and Rotterdam, so it's mainly Netherlands, but also across Europe, in other places, in Switzerland, Austria as well. In the UK, we just started with this, so it's quite new for us to bring it to the market. So we have a demonstration set. If anybody is interested to have a demonstration, we have a unit that we can fix to the train and do a demonstration of how it works and what it will bring to you. I'm not 100% sure how long, but as far as I know, it's been quite a while that it's been in Amsterdam and Rotterdam, and also Switzerland and Austria.
And you mentioned London Underground. What's the link with London Underground?
Well, London Underground at this stage is we're working with them to try to get a demonstration for them as well. So what I said with London Underground is when you have tunnels, you then can't use the GPS system to do it. So any place where you have quite a amount of tunnels, or where the trains predominantly run underground, you need to use a different system than a GPS. So we need to collect data from the trains, and we will have to discuss that with the fleet.
Okay, thank you, Frans. A couple of people asked about the application of this in Network Rail in the UK, and I guess from what you've said that there isn't yet an application. So if I'm wrong, please tell me where it has. But also this question that follows from that is Pat asked, how do your systems compare with the ultrasonic scanners used by Network Rail? For example, the new management train and modular systems.
As far as we know, it will basically be an enhancement of those systems. So with the ultrasonic systems and also the camera systems that's currently used, you do record everything, and it's the same thing. You have to use AI to pick up the noises and the issues that you then detect with those type of systems. This is very similar to this, but it's a different type of way of monitoring it. So you use noise and vibration, which is specific then to damages that you can pick up. So when you have a specific noise, like I said, you have a specific vibration or a specific frequency, and of course those frequencies makes it then easier to pinpoint where and what type of issues you have. So it's I would say if you have that in as well, it's just another piece in the puzzle to make the analysis easier of where issues are.
Okay, thank you. Now, I've got two questions that are along the same sort of lines. So Sebastian asked, is there already some feedback on use of such systems on high-speed lines greater than 250 kilometers per hour? And then Lee Chen Chun asked, what's the maximum measurement speed of such equipment?
Oh, that's very good questions. And I have to be dead honest, I don't know. I'll have to find out what's the maximum speed on this. I got no idea what's the maximum speed that they tested to. So
Okay.
I'll have to get back to them. I can get back to you, and then we can send the answer through, or they can just send me an email, and I can answer them. I'll find out what it is.
You've just given me a very good prompt, because after the session's finished, what we'll do, we'll have a dedicated LinkedIn channel. That gives people on the call, and in fact people that haven't been able to get on the call, the opportunity to ask questions and get some feedback. So what we'll do is we'll get certainly those two and whatever else is left over put on the LinkedIn channel, and then hopefully they can be answered.
We'll do that.
Stuart, sorry
Yes,
to
who's
disturb. It's Ian Stanworth here.
Hello, Ian.
As well as being a member of the PWI, I'm actually a noise and vibration consultant for a living, so I know a little bit about the sorts of equipment.
Yes, sir.
And your standard sound level meter has a sampling rate on fast of either 100 or 125 milliseconds.
Okay.
So how that relates to distance moved in that time is an interesting one, isn't it? You might need more bespoke equipment with a higher sampling rate if you're going above, well, let's say 250. I couldn't give you the speed, but
yes, and that's why I say I can't answer that question. I'll have to go back and just speak to our partners to find out what is the sampling rate that they can do at those specific speeds.
And Ian, thank you for cutting in at that point. But again, it may well be very interesting if you can contribute to the LinkedIn channel afterwards to make sure that there's correct understanding and debate around this particular issue. That would be great.
If I can, I will do what I can.
Fantastic. Thank you very much, Ian.
Thank you.
Sorry, Frans, go on.
No, I'm good.
I will go actually. Yuheng, you've raised your hand. Would you like to unmute and ask a question? Because I'm assuming it's not in the chat at the moment.
Hi, I'm in the chat.
Yes, you are. Sorry.
Yes. Yeah.
Please ask your question.
Yeah, I'm just wondering if the data that your system processes, is it able to be imported into some kind of the CMMS that is already in the market, like for example by Bentley, because it would be helpful if the infrastructure manager can view the data from your system and also from other recording, for example the track recording systems, like side by side. Is it able to do that?
Okay, let me just clarify your question. So you want to know if it can be brought into a system that's already in place in your company. Is that right? Is that your question?
Yes, correct. Like for example, if my railway line has implemented some kind of a CMMS, and then we have a platform like for example from Bentley, then we bring in all the data, including the ones from the recording cars. And I'm just wondering, does your system is also compatible with that system as well? I mean, have you guys done that before?
Well, I'm not aware that our partners have done that before. I haven't seen it as well, but it's not to say that we can't do it. It's another point that I'll have to find out from the powers to be, just to find out if they can integrate that into another system where it works with various other testing platforms as well.
So perhaps that's one for the debate afterwards as well.
Yep.
Be great to get that clarified. And so, thank you very much, you.
Thank you.
Thank you.
Another interesting question, I think, from Jake. Is the system compatible with third, fourth rail areas, or does the noise created by the conductor's shoe affect the results? Sounds a great question.
Again, that will be, like I said, is each train where it operates will have different noise, and of course third and fourth rail will definitely give you those noises. So due to those noises, it will definitely then be programmed into the algorithms, and the AI will eliminate those specific noises to give a better understanding or better result for the for your wheel rail interface noise that's created. So yes, it can definitely eliminate those. I won't say eliminate, but it will take it away in the readings, so you have a more precise reading.
So effectively, it would be compatible for use in third, fourth rail areas. I guess that coincides with your interest with London Underground as well.
Exactly. Yes. Yeah, and it's not just London Underground. If you there's some other places where we're working as well, and they also have third and fourth rail as well. So we can't see any issues with it.
Great, thank you. Malcolm Dobell, or Dubell, my apologies if I pronounced your name wrong. Would you like to unmute and ask your question, Malcolm?
Hi there.
Hi there, Malcolm.
My question's about the train fleets that have had tri-axial accelerometers fitted to every axle on the fleet to help them assess wheel tread condition and sometimes hunting. And I wonder whether the data from those systems can be fed into your systems then to help analyze track issues.
So the accelerometers is fitted where? On the trains, on the axles of the train?
On the axle bearings for every axle on every train, so they can monitor wheel tread conditions and perhaps ride issues like hunting.
I would say yes, it's something that can be looked at and see if those data can be utilized into the system, brought into the system to to have the algorithms look at those specific ones as well. So as a short answer, I think yes, it can be.
Okay,
but it is something that needs to be investigated.
Okay, thank you.
Thank you. I've got a question. I've got a question from Crams. Is rail wheel interface the primary driver for reduction of train traffic noise and damage to the rails? Does data collected feed back to bogie and wheel flange maintenance as a corrective measure?
Sorry, can you just repeat that again, Stuart?
Well, I'll tell you what, Crams, are you online? And if so, could you unmute and possibly ask the question in a better way than I did? Are you there, Crams? Sounds like a no. So in that case, I'll ask again. Is rail wheel interaction the primary driver for reduction of train traffic noise and damage to the rails? And does data collected feed back to bogie and wheel flange maintenance as a corrective measure?
Rail will integrate the primary driver for the reduction of the train traffic noise and damage. Yes. So the rail wheel interface, actually that's what we're looking at. As a reduction for the train traffic noise. So the train traffic noise that he's talking about is, I would primarily say that it is the squealing and the flanging noises due to the wheel rail interface that we're looking, and of course corrugation as well that's been mentioned. So the answer on that is yes. That's the data collected feedback for bogie wheel flange maintenance as a corrective measure. Maybe not so much for the bogey, but for the wheel flange maintenance, definitely yes. So if you have maintenance that so let's assume there's lubrication on your system, whether it's on the track or whether it's on the fleet. If that system is not working, it's going to cause an increase in your noise, and of course, then that will lead then that you need to do maintenance on those. So on both the answers, I'd say yes.
Okay, thank you, Frans. Susan asks, can this be used as an alternative to fixed assets such as wheel impact load detectors?
Oh, I don't know. I can't answer that question. I would rather not go into saying yes. It's something also. Then I'll have to have a chat with the guys on our side to find out. But I'm not sure. I can't answer the question.
No, that's absolutely fair. Much prefer to be honest in this, Frans. That's absolutely the way to do it. And what we'll do, Susan, we'll put the question in the LinkedIn link at the end, and so hopefully Frans can go away and get an answer for you.
Yep.
So I think the last question I've got is about pantographs. For pantograph, how do you take into account the ambient temperature? I guess the stiffness of the OLE varies with the temperature, e.g. change in tension.
Okay, so pantographs is not my forte, I'd say. But the answer I think would be is that you need to have baseline information. When you start with any of these tests, you'll need to have baseline information. And that will also then have to take in consideration your temperature changes, how everything will react due to that or during temperature changes, and how your vibrations will be affected and your noise, but mainly vibration will be affected on the pantographs. So yeah, it will basically come down to baseline information that's needed, and then of course the algorithms will be written to compensate for that.
Right, thank you, Frans. I think that gets me to the end of the questions, because in one way or another we've answered most of them. So on that basis, Frans, thank you very much for giving us an hour and effectively giving what amounts to about 150 people an hour of continuous professional development whilst they're eating their lunch. That's fantastic. So thank you very much for that.
Thank you very much.
As I mentioned, what we'll do, we have a LinkedIn page, and we'll get the questions that we couldn't answer today up on the link. And also, if anybody has any queries or questions that they'd like to raise that they didn't get the opportunity to now, then feel free to put it on. And we'll do our best to facilitate the interchange and get the questions answered. So the other thing I'd like to say is, probably that we do this session every 2 weeks. The next one I've already mentioned is in 2 weeks' time on the 11th of June. That's hosted by the S&C Alliance team. But the following one on the 25th of June, a slightly different subject. It's about satellites and soil moisture, all about advances in asset resilience in the face of climate change, what you can see from satellites that give you the information you need to know where you're going to have a problem. So that'll be a very interesting one. So on that basis, thank you very much again, Frans.
Thank you.
And I'll close the session and say thank you to everybody who's attended. Enjoy the rest of your lunch, and hopefully see you in the future. All the best. Cheers. Bye-bye.
Thank you very much.